noticed that some things tend to float on other things? Like if we take a salad dressing, the oil seems to always want to float on top of all the other stuff that's in the vinaigrette. Or have you ever noticed that when you attach a balloon to a string that's filled with helium, the balloon floats in air and it wants to float away from you? Well, these are concepts that we talk about in secondary 3, and the concept is density. And so in this video, we're going to be talking about 3 things. We're going to be talking about what is density. We're going to talk about how is density described, defined, and determined, and then how is density used to describe substances. So in order to really understand the concept of density, we need to kind of go backwards to our Sec 1 and 2 knowledge and look at mass and volume. So we're going to start with mass. So if we remember from secondary 1 and 2, mass is the amount of matter in a substance. So how much stuff is there in a substance? And we know, if you remember, that we measure our symbol for mass is a small m. And we also know that these are can be displayed in different units. So our units for measuring mass are milligrams. We also have grams, and we have kilograms. Those are how we measure mass. And if you remember, you have this lovely little instrument here called the triple beam balance. So we place our object on the triple beam balance to find out how much matter is in that substance. And it's measured in grams, milligrams, or kilograms. The next concept we need to remind ourselves about is volume. And volume is the amount of space occupied by a substance. And so when we're talking about volume, we need to refer to the symbol V. V for volume. And volume is usually expressed when we're talking about liquid specifically, milliliters and liters. And we usually use a graduated cylinder to help us measure volume of liquids. However, sometimes we might need the help of what's called an overflow can. And that's when we use, when we're trying to calculate the volume of solids. And so solids are expressed, we use centimeters cubed, we use cubic meters, meters cubed, etc., to express volume of solids. And in order to do that, if you recall, we used a overflow can and a graduated cylinder. We can also use these units of measurement for gases. So here's a question for you. Mass and volume are characteristic properties. True or false? The answer is false. So a characteristic property is a property that can be used to identify a substance. So let's pretend that we have an unknown substance that's 30 grams. Well, that's not enough to identify the substance. If it's 30 grams, it could be a 30-gram pencil, it could be a 30-gram strawberry. So the mass is not enough to identify a substance. If we look at volume, volume is also not enough alone to identify a substance. If we have 30 milliliters of a substance, that could be 30 milliliters of mercury or 30 milliliters of melted chocolate. It's not enough to identify the substance. But if we have put both of those two together, mass and volume, something pretty cool happens. We get density. Density is the ratio between the mass of a substance and its volume. And density is a characteristic property. Every single substance has its own particular density, its own unique density. And so it is identified with the symbol. It's a Greek symbol, and it's a P, but we say rho. And the formula for density, we're using our volume and our mass together. And so we get rho is equal to mass divided by volume. And so that is our formula for how we determine density using mass and using volume. But I forgot one thing, and I left it empty. What are the units for density? Let's ask ourselves that. What are the units of density? Is it A, milliliters by centimeters cubed? B, milliliters over grams? C, grams over milliliters? Or D, grams over centimeters squared? The answer is C, grams per milliliter. The formula for density is mass divided by volume, so the units for density must be units of mass over units of volume. So our units are grams per milliliter, but remember, milliliters are used to describe the volume of liquids. And we also have dense matter that is solid. And so we also can use cubic units. So for example, grams per centimeters cubed when we're dealing with solids. So like I mentioned before, every single substance has a unique density value. So here are a couple of tables where we show you, we have solids, liquids, and gases in these tables. And you can see that silver has a different density than aluminum. Aluminum has a different density than lithium. And so it's really important to remember that that's what makes these substances unique, and that's what makes it a characteristic property. Couple of things we need to remember, though, is that we have certain conditions when we talk about density. We have pressure and we have temperature. Those affect density. So if we're up on the top of the mountain, the air is less dense than, for example, air at sea level. We have to think about those factors when we talk about density. And so here's an example of ethanol, and you can see that there's an example where temperature is different. And so density at 40 degrees Celsius is different for ethanol than its density at minus 30 degrees Celsius. So you can see temperature and pressure also play into how density works in these specific substances. Corn syrup, ethanol, and water are poured in a glass. After a few minutes, they settle into 3 distinct layers. Which layer is on top? Is it A, corn syrup, B, ethanol, or C, water? The answer is B, ethanol. So substances with higher density tend to sink. So honey has a higher density, a higher rho, and it sinks in a cup of tea, which has a lower rho. Cold air has a higher rho, higher density, therefore it will sink to the floor. Oil will rise to the top of a vinegar when you're mixing oil and vinegar together. Helium will also rise when in midair. So these are some examples of substances with certain types of densities. To answer our question, let's compare the density values of the 3 liquids. So first we have ethanol, and ethanol has the lowest density. It has a 0.789 grams per milliliter. Then we have water, and if we look at water, it's at 1 gram per milliliter. And then finally, corn syrup. Corn syrup has the highest density number, which is 1.38 grams per milliliter. So if we take all of those numbers into account and we go from lowest density to highest density, we get something that looks like this, where ethanol is floating on the top, corn syrup is on the bottom, and then water has the middle density in between the two. Therefore, it's going to be in the middle layer. So when we talk about density, we have to kind of be careful because a lot of common popular language will say that something is heavier or something is lighter. So rocks are heavier, oil is lighter. And we want to avoid those terms because they kind of don't mention density. They don't talk about density. So we want to try and say, okay, well, instead of oil being lighter, we want oil to be considered less dense. Rocks, they are more dense. They have more substances per volume. They have more inset, so they're denser. If we talk about oil, it has less particles within a given volume. Therefore, it is less dense. We don't want to say lighter. We don't want to say heavier. So we're going to think about something that floats as being less dense and something that sinks as being more dense. So the mass of an unknown solid is measured using a triple beam balance. Its volume was measured using a graduated cylinder. The beams and the cylinder are shown in the following image. Determine the density of the substance and identify it using the density reference table. So before we get started, we have to start by determining our mass and our volume values. Determine the mass and volume of the substance. Is it A? Mass is 130.8 grams. V is 50 milliliters. Is it B? Mass is 38 grams and volume is 52 milliliters. Is it C? Mass is equal to 138 kilograms and volume is 51 liters. Or is it D? Mass is 138 grams and volume is 51 milliliters. The answer is D. So using what we know from what we just determined from the last question, we can fill in our formula. We write in what we know. So we know the mass is 138 grams, and we know the volume is 51 milliliters. And those are the only 2 things that we need to determine density. Or if you remember what that P stands for, rho. So we put it in our formula. Rho is equal to mass divided by volume. So we will get an answer of 2.71 grams per milliliter. And so we take that density value and we look in our table and we can see that the density almost matches aluminum perfectly. But if you look at the unit of measurement of the table, it's grams per centimeter cubed because we're talking about solid aluminum. But it's not a big deal at all because you can make that a conversion. Grams per milliliter is the same thing as saying centimeters cubed. So at the end of the day, we have 2.71 grams per centimeter cubed. And that is the substance, the unknown substance that we just discovered. Let's move on to our second example. The mass of an unknown liquid is 4,200 grams, and its volume is 4 liters. Determine its density and identify it using the density reference table. So the first thing we're going to do in any question is we write down what we know. So we know that the mass in this question is 4,200 grams. Always important to put your units of measurement. So here we're talking grams. In our volume, it's 4 liters in the question. And we don't know its density. We're trying to identify the density of this unknown substance. However, if I go over to my table of reference and I look at the unit of measurement, it's grams per milliliter. And here I have liters. So I need to make that conversion. So what I'm going to do is I'm going to multiply by 1,000, and that's going to give me 4,000 milliliters. And that is what I'm going to put in my formula because I want it to match with what is in my reference table. So again, we put it in our formula. Rho is equal to mass over volume. Rho is equal to 4,200 grams, which we found in the question, divided by 4,000 milliliters. So our answer is going to have grams per milliliter. And that's what we want because grams per milliliter is in the density reference table. And we get an answer of 1.050 grams per milliliter. So we take that and we come over to our table and we see where it fits. Which one does it look like it is measured with? And here the unknown substance matches with acetic acid. So that is the name of our unknown substance. And now we have time for one final example. Elizabeth pours 35 milliliters of maple syrup over pancakes. Help her determine the mass of this maple syrup. So here is a different type of question. First thing we're going to do, write down what we know. And in the question, they tell us right off the bat the volume. So we have 35 milliliters. But we don't have mass and we don't have density. The mass isn't mentioned in the question and they're not asking for density, they're asking for mass. So we're going to put a question mark for our mass. We need to find where this density is, and we have a table for that. So in the question, they're asking us about maple syrup, and we see that the density of maple syrup is 1.38, and we have to look at the units of measurement in our table, grams per milliliter. So we've got our milliliters. We know that the answer has to be in grams so that it matches. So we put our information in our formula. So we're going to put our rho times volume, okay? So we get mass is equal to rho times volume. So we're moving our formula around, order of operations. Mass is equal to 1.38 grams per milliliter times 35 milliliters. If you put that in your calculator, you should come out with an answer of 48.3 grams. And that is the mass of the maple syrup that she poured on her pancakes. And there you have it, our crash course on density. Remember, density is the ratio between the mass of a substance and its volume. Density is a characteristic property, so every single substance on the planet has a unique density value. Remember that the symbol is that P, that Greek, character, and it's called rho. So the formula is rho is equal to mass over volume, and you can manipulate that formula in any way, shape, or form so that you can find mass, you can find volume, and you can find density. Just remember, the units of measurement are grams per milliliter if it's a liquid, and grams per centimeter cubed if it's a solid. Never forget to write down those units of measurements when you're doing any type of calculation in science, especially with density. Catch you next time.